Hello everyone, let us begin today's work. Let's move on with the numerical portion only. An alpha particle is placed in an electric field of 15 into 10 to the power 4 Newton per Coulomb. Calculate the force on the particle. Now before beginning the question, you should know what is an alpha particle. Now the alpha particle is nothing but the helium nucleus. Hope you all know helium nucleus. We have studied helium as 2He4 and its nucleus consists of 2 protons and 2 neutrons. So the nucleus of helium is the alpha particle. Its charge is 2 times the charge of proton and its mass is 4 times the mass of proton, because proton and neutrons, they are of same mass. So here in the given question, electric field is 15 into 10 to the power 4 Newton per Coulomb. If you calculate charge on alpha particle, it is Q equal to twice E, 2 times the charge on proton. So 2 into 1.6 into 10 to the power minus 19 Coulomb. Now we all have studied formula for force. F equal to QE. In place of Q, we'll write charge of proton and electric field same as given in the question. On multiplying, we come up with 4.8 into 10 to the power minus 14. Now moving ahead with the next numerical, 2 point charges Q1 equal to 400 microcoulomb and Q2 equal to 100 microcoulomb are fixed. They are fixed 60 centimeter apart in vacuum. Find the intensity of electric field at midpoint of line joining them. Here we are provided with 2 charges, 400 microcoulomb and 100 microcoulomb, and they are separated by a distance of 60 centimeter or 0.6 meter. If you check the diagram, point A is having charge 400 microcoulomb and point B, it is 100 microcoulomb. And we have to find electric field intensity at point C, which is the midpoint of line joining AB. Now here, to get field at C, we imagine a unit positive test charge. If you imagine a test charge here, then the charge at A will repel it towards right, while the charge at B will repel it towards left. So the field at C due to Q1 is denoted by E suffix A, which is towards right, and due to Q2 is denoted by E suffix B, which is towards left. If you observe, the vector arrow for EA is greater and that of EB is smaller. The reason is quite simple. Charge Q1 is bigger in comparison to Q2. So electric field EA would be greater than the electric field EB. Now if you observe, these 2 fields are along the same line, but they are in opposite direction. So the net electric field would be the difference of the 2 fields. If you observe, here I have calculated field at C due to charge 400 microcoulomb at A. Formula is 1 by 4 pi epsilon naught. Charge upon distance square, and distance is AC, which is 0.3 whole square, and direction is towards B. Direction is towards B. Similarly, we calculate electric field at C due to 100 microcoulomb at B, and this value is 1 by 4 pi epsilon naught 100 into 10 to the power minus 6 upon 0.3 whole square. It is acting towards A. Now these 2 fields are in opposite direction. So the net field would be the difference, keeping in mind EA greater than EB. So we'll take E equal to EA minus EB. On taking like quantities common, we come up with 400 minus 100 in bracket. And after all solution, we come up with 3 into 10 to the power 7 newtons per coulomb. And if you check in the bracket, it is written here towards B. Why? Because field E suffix A is greater than E suffix B. So the net field would act in the direction of EA. That means towards B. That's why towards B is mentioned here. Now moving ahead with next numerical. This one is pretty simple. Now here we are provided with two charges, plus 5 microcoulomb and minus 5 microcoulomb, and they are separated by 1 millimeter. We have to find the dipole moment. Hope you remember the formula for dipole moment. P equal to Q into 2L. Charge is given to us, 5 into 10 to the power minus 6, and 2L is the entire distance, which is 1 millimeter, 10 to the power minus 3 meter. Just applying the values, we'll get the answer for dipole moment.